mini lecture is designed to show you how to split salts or ionic compounds into their component ions. This is a very important thing to be able to do for both for KSP problems and for precipitation type problems. So I think the first thing that you should do is you should take the compound and then try and draw a picture of it. So if you've got FeBr3, we can see there's one Fe and there's 3 Brs. Often the challenge here is to know whether there's 3 separate Brs or whether that is part of a polyatomic ion. Well, it's pretty easy to tell if it's part of a polyatomic ion because there will always be more than one element present in the anion part of the molecule. So this is an example of a polyatomic ion where you've got a Cr and an O, and that's clearly on the negative side of that ion, negative side of that compound. And this one is also a polyatomic ion because you can see the P and the O here. So that's not really that big a deal as long as you look for the single element. Now the next thing you need to be able to do, I think, is, especially for single elements, you need to be able to identify their charges by looking at them on the periodic chart. Here's an example of how to do that. What we usually find is that these group 7 compounds are -1, the group 6 ones are -2, nitrogen is -3, and usually we don't go too much further than that. Alright, so if we know that, then we can go ahead and put charges on our at least negative part. That's a total charge of -3. Now one thing about these ionic compounds is that they have equal charges on the positive and negative side. So that one's -3, which means this side must be +3. Since all we have over here is an ion, then that's going to be Fe3+, and now we can figure out how it's going to split apart. FeBr3 will split into 1 Fe3+ and 1, 2, 3 Br minuses. So it's just really a matter of counting the ions. Alright, that's for that one. Let's take a look at something a little bit more challenging. We'll look at S and S2. So that's going to be Sn and then 2 S's. Now we have to look at the periodic chart to see what charge sulfur is going to have. And we can see that sulfur's in group 6, so that's going to have a -2 charge. So I'll put -2 and -2 here. That means the total negative charge on here will be -4, which means the total positive charge on here must be +4. So tin will have a 4+ charge. Alright, so now we can go ahead and see how that splits up. And it will split up into 1 Sn4+, and let's see, 1, 2, plus 2 S2 negative. Okay, let's take a look at this next one, iron, the Fe2CrO3. Okay, so what I see here are 2 Fe's and 3 separate CrO4s. Remember that the number on the outside of the parentheses tells you how many of that group you actually have. That's 2 negative, 2 negative, 2 negative. So you would hope that you would have enough information to at least be able to figure out the charge on this ion. You might get the information from somewhere else in the test perhaps. And here you've got to figure out what the total negative charge is. That's -6, which means the total positive charge is +6. So my next mission then is to look at this and figure out what charge Fe would have to have, each Fe would have to have, so they total out to positive 6. And that would be 2 Fe3 pluses, like that. So the Fe2 CrO43 will split into 1, 2 Fe3 pluses and 3 chromates. There we go. Alright, the last one, Cu3PO4. Do it up here. What we've got here is 3 coppers. And then we've got to do something important here. Look at the PO4 and make sure that it is, see if it's a single element or a polyatomic ion. If it's a, it's not a single element because we've got a P and an O here. So it must be a polyatomic ion. And what it must be is just one PO4. Not 4 POs or anything like that, just one PO4. Now if we know that the charge on phosphate is -3, then the total on this side is going to be -3, which means the total on this side has to be +3, which means each one of these would have to have a positive charge. So Cu3PO4 will split into 3 Cu plus, see 1, 2, 3, and 1 phosphate. The most common mistake people make here is saying stuff like there's 4 POs or that kind of thing, and that just doesn't work out.